Hi everyone, welcome to another video in the series of working with data using Apache Spark. And in this video, we'll specifically take a look at what uh, Apache Parquet is and how does that relate to Apache Spark. If you're coming from a Hadoop background, chances are you've already encountered Parquet in the past or heard of it. If not, Parquet is a top-level Apache project and gained significant momentum over the past couple of years, basically since its inception. And Parquet is what's referred to as a columnar storage format. So that's an important thing to keep in mind. It's a storage format, or facilitates a kind of serialization, if you will, that optimizes various storage and data I/O related aspects. So in this video, we'll take a look at a quick overview of some of the key benefits of using Parquet as a storage format. We'll try and understand why you can consider Parquet, and finally we'll take a quick look at a few demos around using Spark with Parquet. So moving on, so the first plan of action is just quickly to address some of the key benefits of using Parquet. So while there are significant other benefits that I've not listed here, I would say these are probably the top reasons why Parquet can potentially make a lot of sense within your projects. So you can imagine when working with big data projects, while storage in itself is not very expensive, optimizing storage, like say for example, if you're in the terabyte regions, even optimizing 5-10% of the storage can be quite significant. So Parquet allows for a much more optimized and compressed data storage. So there's a lot of efficiencies when using Parquet, primarily from a storage standpoint. Moreover, the other key benefit of using Parquet, apart from a more efficient storage, is how Parquet can be more efficient at doing data I/O style operations and resulting CPU kind of like benefits. So to help me drive the point around efficient I/O in a bit more detail, I've used this visualization from a search or Google. But basically the idea is this. So let's say you have a table which has columns A, B, and C, and this is your standard row and column format. So here we have 5 rows here and 3 columns. So how would you store this information? So what kind of serialization and storage format would you consider? So Parquet is actually, before I get to Parquet, just highlighting that if you're using the standard way of storing the data, it uses kind of like a row kind of like layout. So that basically means that the first row is written here, and then the second row is written, the third row, and the fourth row, and then finally the fifth row, and kind of like written in a sequence. So it's kind of like appended that way. And while this might seem okay at first, the way Parquet or a columnar layout kind of like addresses that is it actually stores all the columns first and in that order before storing the next column. So it's exactly the same data set, but if you're using a columnar storage format, it actually stores all the first column. So you can see A1 through A5, the values of those columns are stored first, and then the second column data, and then finally the third column data. At first glance, this might seem like, that doesn't sound right. But there's actually a lot of optimizations by storing it in this format. It also depends on how you're querying the data, but think of most of the queries that you have written or planning to write in Spark. It might be a case where you're selecting a few columns and filtering it by, say, a third column. Say you want to select A by filtering for column C. So if you're looking at it from the row layout format, it's a case where you pretty much have to read every column in order to, or every set of data in order to get to the result set. So that basically implies that you need to pretty much scan the whole data set or scan the entire file, but we only needed to read a few blocks, and that's what a columnar storage really allows. So say for example, if you were to do a filter for C column, so we know already it's basically an offset here, so it can readily find all the information, and we can query and filter for C, and as a filter use column C, and then finally say for example return column A values. So that's basically the key strength of looking at a columnar storage. Apart from that, by storing it in a columnar fashion, there's quite a lot of efficiencies in terms of how we can encode the data and give us resulting performance benefits and compression and storage optimization, and of course improved I/O. So as an example, if say imagine if column C was being used to store, say, states in the United States. So there are 50 unique values, and we could use things like a dictionary encoding behind the scenes. So that results in quite a lot of storage optimizations here. Or the other classic example of things like timestamp. So imagine, if you will, if B was a timestamp, a date timestamp. So then in that case, that's can be challenging, but still we can look at approaches like using delta encoding. So that's more incremental. So if it's like a timestamp and it's only the seconds or the milliseconds, for example, that are changing, then we can actually use delta encoding for things like timestamp. So hence why we see that there's quite a lot of data efficiencies, and in terms of I/O and resulting CPU optimizations looking at a columnar storage. Then finally, the last key benefit I'll highlight is interoperability. So as I mentioned early on, Parquet is a columnar storage format for Hadoop, the ecosystem. So it's very popular in part because you don't have to worry about different projects having to have that complexity of understanding the storage formats. Parquet is universally understood by almost all the Hadoop projects. So if you are working in Spark and HDF Hadoop environments, or if you need to work with Hive or Impala or various other Hadoop ecosystem-based projects, then Parquet is very much interoperable. Parquet works by storing the schema along with the data, so it's basically a self-contained structure. So that basically implies that the schema itself is stored along with the data. So it's well understood. It's self-describing. So different projects outside of Spark, if Spark's writing the data or reading from the data, and you have so if you have another project doing the reverse, then it still can talk to one another using that same well understood interoperability. So that's it for concepts. Let's actually see some examples of Parquet and Spark in action. In my environment here, I've got Spark 1.6 pre-set up, and to see some examples, so I will run through two instances. So here I've got an example of a JSON file, and we'll take a simple example of converting JSON to a Parquet example. So if I go to the examples folder here, so that's nanopeople.json. So this is the file. So very simple, nothing too complicated about this file here. It's basically got two columns, name and age here. So the first thing we'll do is we'll load that data. So I've already got a Scala shell running here. So I've opened Spark shell, and here I can paste that there. So we have just loaded that JSON data into a data frame, and now we can actually take that data frame and take the two columns that we are selecting here, and we can save that into a Parquet file. So Parquet as a format isn't a file itself, so I'm just correcting myself. Parquet behind the scene, when we are storing it, it actually stores it as a directory structure. So I've opened Spark shell from the Spark folder here, and hence what happens is it creates that folder here. So you'll notice the command that I've issued is to write it to a Parquet storage called names and age. And here, as a result of that operation, you can see that it did create a folder called names and age. So let's look at names and age. Let me just clear that. So here, so this is what gets written behind the scene. Again, it's not going to be feasible to look at the files itself on the command prompt here, but just to give you an idea in terms of the actual structure of the directory that gets created if you are using Parquet. So of course, in this case, it's on my local machine. In almost all cases, chances are you will be using it on a different storage subsystem, something like HDFS, for example. You might have Parquet files either pre-created, and you may want to load it in Spark, or Spark might create Parquet files. In this example, of course, I've created a new Parquet store. In the other option is I could append into an existing store, Parquet store. So that's one example. Let's try another example. So here I've uh, I've got another example where, let's say, the data that you had wasn't really JSON. So I've just created some data. So we've got data in a RDD, and we'll convert that into a data frame, and finally store that as a Parquet, and finally we'll read that Parquet back into a different data frame and see the end result. So I'll just copy that whole thing, and let's just paste that there. All right, so that's it. So you can see it's we have basically created an array, put that into a data RDD, change that to a data frame, store that as a Parquet, and then retrieve that back. So as you can see, it's fairly easy to work with Parquet. So again, regardless of whether you used a JSON data, or if you've used some other format, it's ultimately being stored as a Parquet directory. So similar to the previous example, as you can see, it creates these folders. So that's Parquet in a nutshell, and we'll cover more about different formats in future videos. So look forward to seeing you in the next video series. Thanks everyone for watching.